I'm going to give you some tips for post-lab 24, a green synthesis of adipic acid. The first question, you're just reporting your data from the lab. Cyclohexene could be measured either by its mass or by its volume, so make sure that you specify which units you're using when you report how much cyclohexene you started with. Your product and then your melting point of your product gets reported here. In problem number 2, you're going to be calculating your yield, starting by calculating the millimoles of cyclohexene. So up here, if you measured cyclohexene by volume, so if you had the volume of cyclohexene and you used milliliters as your units, in order to calculate the millimoles of cyclohexene, you're going to need to convert from milliliters into grams first, and then you can convert from grams into moles, and then of course into millimoles. And because we don't often do this conversion in organic chemistry, I want to remind you that to do this, you're going to use the density of cyclohexene, which is in your textbook in table 24.1. It's page 209. It does give you the density, which is 0.809 grams per milliliter. And that's the conversion factor that you're going to use to convert from grams into milliliters. Next, you're going to calculate the theoretical millimoles of adipic acid, the chemical equation for this to give you the stoichiometry. That equation is also on page 209, right above that data table. You can, once you know the millimoles of adipic acid, you'll calculate your theoretical mass and then your percent yield, which is going to come from the mass that you actually synthesized over the theoretical mass. In problem 3, you're going to be analyzing your purity based on your melting point and then also based on the IR that you took of your product. And this is, more of an art than a science. There isn't really a specific rule that we say, okay, now based on, this particular melting point, I'm going to call it pure or I'm going to call it impure. You just kind of have to go with your gut. A very pure, in order to have a very pure substance, the melting point should be right at 152. I would say plus or minus a degree, just to give a little bit of room for error on the melting point machine. And you also want to have everything melting at 152. So I would say no range, meaning it doesn't start melting at 152 and then finish melting at 153. You don't want to see something like that. That would be very pure. A pure substance would be something that's close to this criteria, maybe it's within 2 degrees, maybe even within 3 degrees. I would go ahead and call pure, as long as it doesn't have a range or doesn't have much of a range. So maybe, and this is just me coming up with this stuff randomly, don't take this as gospel, maybe 152 plus or minus, we'll say 2 degrees. And then maybe a range of only 1 degree. So we'll say a 1 degree range. And again, I don't know, maybe I should be more generous than that. You can just kind of I feel bad writing this stuff down because I feel like some of you are going to take it as gospel. Just kind of go off of your instinct. Very impure, I would call that nowhere near 152. Is something that is a melting point that isn't even close to this, it's a 200 degrees or it's 90 degrees or something, not even close. Impure would be something that is kind of in the ballpark of 152, but it's off, maybe 10 degrees off, or maybe a really wide range of melting points. I think that when you see your data, you'll be able to classify it. People usually are harder on themselves than they need to be. And I want to erase these again because I know that some of you will take it as the gospel and it's not. Now, with your IR, rating the purity of your based on your IR, if your substance has no resemblance, if your IR has no resemblance to the IR of adipic acid, that's going to be very impure. If you see some similarity, call it impure, just not very, if you see some but not much. If you see all of the same fundamental peaks, remember sometimes in the fingerprint region there might be some things that don't show up. in your IR, but if all the fundamental peaks are there and everything looks really good, call it very pure. If you have like a key peak that is missing or something looks a little bit funny, maybe call it pure. You really can't mess this up. You're just being asked to analyze and interpret your data. There isn't really a right answer to this question. This is kind of like your opinion based on your data. Problem number 7 on page 211 gives you the structure of a molecule called 5-oxohexanoic acid. I'm going to draw the line structure right here. CH2, 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 COOH. And it's asking you to, the problem itself is asking you to come up with a strategy for synthesizing this, but I just want you to identify the starting alkene. So what alkene would you start with to synthesize this particular molecule using the same process as we used in this lab? And then last but not least, you're going to make a flow diagram for the experiment. This one's pretty big. Notice on this one that you need to enter in the lab, I'm going to call them functions. I don't know if that's really the right word, but you've got crystallize in here as a choice. You've got decant and you have reaction. So those are your operations. That's the right word. And those are going to need to go into these boxes that are on the arrows, indicating each one of these different operations. So as you remember, this first spot is where you're going to be putting all of your reactants. And then this is where you're going to be writing in the products of that reaction. Once you get to this part on the flow diagram, these 4 substances are going to be carried down into these 4 boxes. So everything that you have here needs to show up in one of these 4 boxes. And whatever this is, it looks like this is the end of its route. And then these 3 substances are being carried down here. So whatever you have here, they need to show up in these 3 boxes. And it looks like this is your pure final product right here all by itself.